Right, today in Algebra 2, we're going to look at section 7.3, trig functions and real numbers. After today's lesson, we will be able to use the unit circle to evaluate the exact value of trig functions of any angle. So recall, first, our unit circle, we're going to fill everything in. So if I do all of my angles in both degrees and radians, so I start at 0 degrees or 0 radians. 30 degrees, which is pi over 6 radians, 45 degrees, which is pi over 4 radians, 60 degrees, which is pi over 3 radians, 90 degrees, which is pi over 2 radians, 120 degrees, which is 2 pi over 3 radians, 135 degrees, which is 3 pi over 4 radians, 150 degrees, which is 5 pi over 6 radians, 180 degrees, which is pi radians, 210 degrees, which is 7 pi over 6 radians, 225 degrees, which is 5 pi over 4 radians, 240 degrees, which is 4 pi over 3 radians, 270 degrees, which is 3 pi over 2 radians. And then our fourth quadrant, 300 degrees, which is 5 pi over 3 radians, 315 degrees, which is 7 pi over 4 radians, 330 degrees, which is 11 pi over 6, sorry, that's 11 pi over 6 radians, and 360 degrees, which is 2 pi radians. So now we want to do all of our x's and y's. So this is the point 1, 0. So that means this is the point square root of 3 halves, 1 half, square root of 2 over 2, square root of 2 over 2, 1 half, square root of 3 over 2. This is the point 0, 1, which makes this the point 1 half, square root of 3 halves, square root of 2 over 2, square root of 2 over 2, square root of 3 halves, 1 half. All of my x is negative here. This is the point negative 1, 0. So then that makes this the point negative square root of 3 halves, negative 1 half, negative square root of 2 over 2, negative square root of 2 over 2, negative 1 half, negative square root of 3 over 2. This is the point 0, negative 1, which makes this the point 1 half, negative square root of 3 halves, square root of 2 over 2, negative square root of 2 over 2, and square root of 3 halves, negative 1 half. And then we just remember that all of these x comma y is really cosine comma sine. So today's lesson is all about using that unit circle to find the exact value of any angle that is on that unit circle. So number 1, what are the sine and the cosine of the angle 2 pi over 3? So I want the sine of 2 pi over 3 and the cosine of 2 pi over 3. So we look at our unit circle, 2 pi over 3. That's the second quadrant right here. So the sine is the y value, square root of 3 halves. The cosine is the x value, which is negative 1 half. Those are our exact answers. You will never give me decimal answers on these. So number 2, what are the sine and cosine of a negative 45 degree angle? Negative 45 is the same thing as 7 pi over 4. So this is the same thing as 7 pi over 4, because remember, negative just means we start at 0 and we go clockwise pi over 4 degrees. So the sine of negative 45 degrees and the cosine of negative 45 degrees. I look at my x's and my y's. My x value is the square root of 2 over 2. So the cosine of negative 45 is the square root of 2 over 2. The sine, the y value, is negative square root of 2 over 2. So turn it over. Number 3, what are the sine and cosine of 4 pi over 3? So again, cosine of 4 pi over 3, sine of 4 pi over 3. We're giving exact values. So we find 4 pi over 3 on our unit circle. We see that that is the same thing as 240 degrees, or quadrant number 3. So I know that both of my answers here are negative. So the cosine is negative 1/2. The sine is negative square root of 3 over 2. And number 4, what are the sine and cosine of 3 pi over 4? So the sine of 3 pi over 4, the cosine of 3 pi over 4. Again, we go back to our unit circle. So at 3 pi over 4, our y value is the square root of 2 over 2. Our x value is negative square root of 2 over 2. I want to go back and just talk about something real quick on the unit circle. Our quadrants, okay? If we remember, okay, a smart trig class, okay? So a smart trig class, that tells me that all of the trig functions, all 6 are positive in the first quadrant. If I look at the second quadrant, right, I have smart stands for sine, and its buddy, the cosecant, are positive in this quadrant. Everything else, all the 4 other trig functions will be negative in quadrant 2. Quadrant 3, the t goes with tangent and cotangent are all positive in the third quadrant. Everything else, the other 4 trig functions will be negative. And then finally, quadrant 4 is C. So this is cosine and its buddy secant. Those are the only 2 that are positive in this quadrant. Everybody else will be negative. All right, so now we're going to go back to the second page. We're going to talk about some identities. So the very first one, the Pythagorean identity. The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. So we're going to use the Pythagorean identity to help identify the missing coordinate. So if we are given that the cosine of theta is equal to negative 3/5, we want to solve that for the sine of theta. Okay? So if the cosine of theta is equal to negative 3/5, I need to figure out what quadrant are we talking about. Okay? We can go ahead and do the Pythagorean identity first. So if I do sine squared theta plus cosine squared theta, well, cosine is negative 3/5, then I'm going to square that. I know it has to equal 1. So I get sine squared theta plus, I'm going to square negative 3/5, so I square top and bottom, and I get 9/25 equals 1. I'm trying to solve for sine, so sine squared theta equals 1 minus 9/25. So here I have sine squared theta. I'm going to get a common denominator, so really I'm going to make this 25 over 25 minus 9 over 25. Then I get sine squared theta equals, so 25 minus 9 gets me 16/25. It just asked me for the sine, so I have sine squared, so I'm going to take the square root of both sides. So then I get the sine of theta equals, I put the square root in the problem, so I have positive and negative. The square root of 16 is 4, over the square root of 25 is 5. But now I need to figure out what quadrant I'm in so that I know, is my answer going to be the positive 4/5 or the negative 4/5? So if I'm looking at the cosine of theta equals negative 3/5, I know that the cosine, I'm sorry, I need to give you the information here. So we're talking about this angle is going to be in quadrant 3. Okay? So if the cosine of theta is negative 3/5 and I'm in quadrant number 3, okay, so I'm down here somewhere, a smart trig class, so T, tangent, and cotangent are the only ones that are positive in quadrant 3. So then I know my answer, I'm looking at the negative answers. So the sine of theta is negative 4/5. There's our answer. Number 2, what is sine theta if cosine theta is the square root of 2 over 2 and theta is between 0 and pi over 2? So we're looking at quadrant 1. So we're in quadrant 1 where everything is positive. So I know that I'm going to be using my positive answer. So I can do sine squared theta plus cosine squared, square root of 2 over 2 squared equals 1. So sine squared theta plus the square root of 2 squared is 2 over 2 squared 4 equals 1. Subtract 2/4, which is really just 1/2. Sine squared theta equals, so 1 minus 1/2 is 1/2. Take the square root of both sides. We already know that we only want the positive, so sine of theta equals the square root of 1 over the square root of 2. I can't leave my answer like that, so I need to rationalize, multiply top and bottom by the square root of 2. So I get on top the square root of 2 over 2. So the sine of theta would be the square root of 2 over 2. Okay. Or I could look at my unit circle. If I know that the cosine of theta is the square root of 2 over 2, and I'm in quadrant 1, I know I'm looking at theta is equal to 45 degrees. Therefore, from the unit circle, I know that the sine of theta is also the square root of 2 over 2. It would have saved us a lot of time. So if you can use the unit circle, use the unit circle. If you can't, so like number 3, what is cosine theta if sine theta equals negative 0.8? My unit circle doesn't have any decimals on it, so I know I'm not using my unit circle. I have to use the Pythagorean identity here. So sine theta is negative 0.8, so negative 0.8 squared plus cosine squared theta equals 1. So negative 0.8 squared gives me 0.64 plus the cosine squared of theta equals 1. Subtract 0.64, so I get cosine squared theta equals 0.36. Take the square root of both sides. So then I have the cosine of theta equals positive and negative. The square root of 0.36 is plus or minus 0.6. So now I have to figure out, do I want the positive or the negative? I'm looking at quadrant 4. So remember quadrant 4, a smart trig class. Cosine is positive, so I'm looking at the cosine of theta is equal to positive 0.6 for my answer. Okay. All right, so now let's recall our trig identities. So remember that our ratios, the sine of theta is equal to the opposite over the hypotenuse. The cosine of theta equals the adjacent over hypotenuse. The tangent of theta equals opposite over adjacent. Therefore, the tangent is equal to the sine, because I have opposite on top, over adjacent on bottom, the sine over the cosine. Okay? So I want to know, what is the tangent of negative 5 pi over 6? And again, I need to tell you that this is in quadrant 3. Right, so quadrant 3, I'm going to go ahead and draw this. So here is my angle. I want to make my reference triangle, so I'm going to make a triangle. So this is my point x comma y, negative 5 pi over 6. So this, what reference angle are we looking at right here? If I'm looking at negative 5 pi over 6, then this is a reference angle of pi over 6. So I could say that the tangent of negative 5 pi over 6 is really equal to the sine of negative 5 pi over 6 over the cosine of negative 5 pi over 6. If I look at my unit circle, I'm looking at pi over 6 as my reference angle. This point then, this xy point down here, is negative square root of 3/2, comma, negative 1/2. So this is negative square root of 3/2, and this is negative 1/2. So the sine at negative 5 pi over 6. That's my y value, so that's negative 1/2. Divided by the cosine, the x value, negative square root of 3/2. I have a fraction divided by a fraction, so I flip the one on the bottom and multiply. When I do that, all of these cancel. My 2's cancel. I have negative 1 times negative 1 on top, so I get 1. Over the square root of 3. I cannot have a radical in the denominator, so I need to rationalize. So multiply top and bottom by the square root of 3. So I get the square root of 3 over 3. That is the tangent at negative 5 pi over 6. So let's try some more of those. So number 2, what is the tangent at 3 pi? So I need to figure out where's 3 pi on my unit circle. Right? So this is 0. This is pi. This is 2 pi. So then back over here is 3 pi. So I'm looking at this point right here. Okay? So pi is the same thing as 3 pi. So that point on my unit circle is the point negative 1, 0. So I know that the tangent of 3 pi is equal to the sine of 3 pi over the cosine of 3 pi. The sine at 3 pi is the same thing as the sine at pi. My y value is 0 over the cosine, negative 1. 0 divided by negative 1 is equal to 0. So the tangent of 3 pi is equal to 0. Number 3, find the tangent of negative 3 pi over 2. So negative 3 pi over 2 is the same thing as pi over 2. So the point that I'm looking at is 0, 1. So the tangent of negative 3 pi over 2 is equal to the sine, which is 1 over the cosine, 0. 1 divided by 0 is undefined. So the tangent at negative 3 pi over 2 is undefined. Let's look at, find the tangent of 675 degrees. 675 is not on our unit circle, it's bigger. So let's find out where that is on the unit circle. So subtract 360 from that. So 675 minus 360 puts us 315. So go to 315 on your unit circle, and the point we're looking at is the square root of 2 over 2, comma, negative square root of 2 over 2. So the tangent at 675 is equal to the sine, negative square root of 2 over 2, over the cosine, the square root of 2 over 2. I have the same thing being divided by itself, but one's negative, one's positive. So when I divide that, I get negative 1. So now we're going to evaluate the secant, the cosecant, and the cotangent of each angle. Remember that the secant is really 1 over the cosine. The cosecant is really 1 over the sine. And the cotangent is really 1 over the tangent. So 135 degrees, look at your unit circle. What is the point on your unit circle at 135 degrees? That is negative square root of 2 over 2, comma, square root of 2 over 2. So the secant at 135 degrees is 1 over the cosine, or the cosine flipped, okay? My cosine is negative square root of 2 over 2. So if I flip that, I get negative 2 over the square root of 2. I need to rationalize my denominator, so multiply top and bottom by the square root of 2. So I get negative 2 square roots of 2 over 2. My 2's cancel, and I'm just left with negative square root of 2. The cosecant at 135 degrees is really just my sine flipped. So my sine was the square root of 2 over 2. But again, when I flip that, I get 2 over the square root of 2. Rationalize the denominator. And I have 2 square roots of 2 over 2. The 2's cancel, and I'm just left with the square root of 2. Now I want the cotangent of 135 degrees. If the tangent is sine over cosine, the cotangent is cosine over sine. So cosine would give me negative square root of 2 over 2 divided by sine square root of 2 over 2. The same thing being divided, so negative 1. So let's try another one. 210. So on the unit circle, that point is negative square root of 3 halves, comma, negative 1 half. So if I want the secant at 210, I'm going to flip my cosine. So I'm going to get negative 2 over the square root of 3. Rationalize our denominator. So I get negative 2 square roots of 3 over 3. The cosecant at 210, flip the sign. So I get negative 2 over 1, which is just negative 2. The cotangent at 210 is going to be cosine over sine, so negative square root of 3 over 2 over negative 1 half. Flip and multiply on the bottom. So then those cancel, my 2's cancel, my negatives become positive, and I'm just left with the square root of 3. Okay, so now we want negative 10 pi over 4. I notice that I can reduce that, so they both have a 2 in common, so this is really negative 5 pi over 2. So if I go to my unit circle, let's see, where would 5 pi over 2 be? And then I want negative 5 pi over 2. So if I look, let's just talk about where would, I know that this is 0, this is negative pi over 2, this is negative pi, this is negative 3 pi over 2, right? So this would be negative 2 pi. All right, so negative 2 pi, right? I have to keep going to get negative 5 pi over 2. This is greater than 360, right? So this is negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2. So this is also negative 5 pi over 2. So it's the same thing as negative pi over 2. So that point down there is the point 0, negative 1. So the secant of negative 5 pi over 2, 1 over the cosine, so 1 over 0, which is undefined. We can't do that. The cosecant of negative 5 pi over 2 is 1 over the sine, so 1 over negative 1, which is negative 1. The cotangent at negative 5 pi over 2 is going to be the cosine, 0, over the sine, negative 1, which is 0. All right, last page. So now we're going to use this to solve some word problems. So it tells me a rescue team is searching a circular area in a 4-mile radius around their camp. The team travels on a path 30 degrees east of south from the camp. What is their final position relative to their camp? So let's draw a picture of this. So this is north, this is south, east, and west. We're starting at the origin. We travel 30 degrees east of south. So this is south, this is east. So 30 degrees east of south. This is 30 degrees right here. I'm going to make my triangle, my reference triangle. I know that it's a circular area with a 4-mile radius. So this is my radius right here. So this is 4. I need to find this point right here. I can go ahead and find out what is this angle up here. So what angle are we looking at? I know that the whole quadrant was 90. This part was 30, so 90 minus 30, this is a 60-degree angle right here. So I know I have a 30, 60, 90 triangle. So I can use my shortcut. So 30, 60, 90 shortcuts. My hypotenuse is 4. So half of that is my short leg. So this is 2. My long leg is my short leg, 2 square roots of 3. But since I'm in the fourth quadrant, my x is positive, so 2, comma, my y is negative, negative 2 square roots of 3. Therefore, I am 2 miles east, because we're going 2 miles in the east direction, and 2 square roots of 3, which we don't know what that is, so we're going to type that in our calculator, or approximately 3.5 miles south of camp. So the rescue team is 2 miles east and 3.5 miles south of the camp. All right, let's try another one of those. What is the final position of a search team relative to the camp if they walk 30 degrees north of due west for 5 miles from their base camp? So again, here's north, south, east, and west. They walk 30 degrees north of due west. So I start here and I'm walk 30 degrees north. So this is 30 degrees. So again, we're going to make our triangle. They've walked 5 miles west, so this is 5. Again, I have a 30, 60, 90 triangle. I can do my 30, 60, 90 shortcuts, right? Or I can look at, right, what angle would this be? So what angle would this be right here to get this point? So I'm just going to show you another way that I could do this. So 180 minus 30 puts me at 150. So at 150, my point is negative square root of 3 halves, comma 1 half. But this was with a radius of 1 on my unit circle. We have a radius of 5. So I would have to multiply this point by 5. So I would find my point to be negative 5 square roots of 3 over 2 and 5 halves. So let's just check that. If I use my 30, 60, 90 shortcut, do I get the same thing? My hypotenuse is 5. Cut that in half to get my short side, so 5 halves. That side times the square root of 3 for my long side, 5 halves square roots of 3. I'm in the second quadrant, so I know that my x is negative, my y is positive. So that gives me the point, negative 5 halves square roots of 3, comma 5 halves, which is the same thing that we got over here. So now let's make sense of what does that mean. Again, negative 5 halves square roots of 3, we're going to go and type that into our calculator. And we find that that turns out to be 4.3. We don't need that negative sign, right? So we have approximately 4.3 miles west and 5 halves, which is 2.5 miles north of camp. So that is the actual position of the search team. They're 4.3 miles west and 2.5 miles north of camp. And so that wraps up section 7.3 for us. Next, we will learn how to start graphing our trig functions.